Hey everybody, this is Mr. Beckstrom, and today I want to look at an example from section 10.2. This says find the equation of the ellipse with foci -6, 0, and 6, 0, and y-intercepts 0, -2, and 0, 2, then find its graph. So once again, let's talk a little bit about what these terms mean and how we define an ellipse and how we would go ahead and graph that. So an ellipse is like a circle, except it's either going to be stretched horizontally from left and right, or it's going to be stretched vertically up and down. And it's going to have a slightly different formula, whether you stretch it horizontally or vertically, and we'll talk about that in just a moment. And the definition for an ellipse is the set of points in a plane such that the sum of their distances from two fixed points is a constant. Each fixed point is called a focus, or plural is called the foci of the ellipse. All right, so what does that mean? That means that if we graph these two foci here at -6, 0, and 6, 0, so let's go ahead and do that. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So these are not actually part of the graph. They're just used to help us graph this ellipse here. And then if we actually draw the circle around them, but we actually have y-intercepts over here. So at this point and this point, we're going to have something that looks like this. And it's going to go around. And I know that does not look like a good ellipse, just pretend that it does. And what it's saying is that if you take the sum of the distances, for example, if you took the point right here and you looked at the distance of it from this point here, and then you added the distance from this foci to this point, if you looked at the sum of these two distances, that's going to be the same sum as if you looked at the sum of these two distances here. And that is one way that we can define an ellipse. And that's the same for every single point on here, that we're going to have this sum here. And that sum is actually going to be equal to 2a. And we're going to talk a little bit about what A, B, and C are as soon as I show the formula. So we're going to have two formulas here, depending on whether our ellipse is stretched horizontally or vertically. In this case, we are stretched horizontally, so I'm going to be looking at that formula. And it's going to look like this. X squared over A squared plus Y squared over B squared is equal to 1, and where a squared is equal to b squared plus c squared, b squared plus c squared. All right, now let's talk about what all of these letters mean, and I'll tell you the difference between the two formulas. So the only difference is that if this thing is stretched horizontally, then our a squared goes under the x squared term here. In the other formula, if it's stretched vertically, then our a squared term goes under the y squared term, and then the b squared term goes first. It goes under the x squared term. So you just switch these two here. This part stays the same where this is true. All right. So what are these three letters? So the A is always going to be the intersect point on the major axis. The major axis is the one that's being stretched. So in this case, the x-axis is going to be the major axis. So the A is going to, for example, be that intersect point. So this will be A0 over here, and this over here will be negative A0. I hope you can see that. All right. B is always going to be the intersect point on the minor axis. That's the axis that's not being stretched. So let me change. So this point over here will be, 0B, 0B. And this point down here will be 0, negative B. And C here, that's the foci there. So let me do that in green. So that is, if we are being stretched horizontally like we are, then that is going to be C0. And over here will be negative C0. All right, so this is how all the three letters kind of correspond. So the A has to deal with the intercept on our major axis, so which is going to be the X when we're being stretched horizontally like we are. The B will be the intercept on our vertical axis, which will be our minor axis in this case. And then, or minor axis, which is our vertical axis in this case. And our C will be the foci points here, which the foci always go on the major axis. So when it's being stretched horizontally, it'll be on our x-axis, and when it's being stretched vertically, it'll be on our y-axis. All right, so we have most of this already here. So already I can go like this. X squared over a squared is equal to y squared over, and our b, we already know that's going to be 2 there, so that's just going to be over 4, because 2 squared is equal to 1. So the only thing I really need is a, so I'm going to use that equation over here. So a squared is going to be equal to b squared plus c squared. So b squared is going to be 4, because that's 2 squared, plus c squared, that's going to be 6, right? Because that's our c plus, so that's 36. So a squared is going to be equal to 40. So I can just replace this down here with 40, and I'm going to get x squared is equal to 40. This should be a plus here. Plus y squared over 4 is equal to 1. And then I know that these points here are going to be the square root of 40, right? Because that's my a. So if I want to kind of get a good idea of where the intersect is on my x-axis, I can just take out my calculator and I can do the square root of 40, second square root of 40, and I get 6.3. So it's just beyond the foci there. So I went a little bit too far in my thing. So if I was actually graphing this, the foci is at 6, so it's just barely beyond my foci there. It's right about 6.3. All right, I hope this helped. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.